All right, so today we're doing section 5.8, solving rational equations. So rational equations basically mean that these are equations made by adding and subtracting fractions, okay? Um, and those usually won't be too hard to do if all the fractions have the same denominator, but they don't, okay? So I put right here common denominator. What are common denominators is when fractions have the same denominator. They are found by doing the GCF for each denominator. In other words, looking at the denominator and saying, what can I make them all look like? Like, can I get one of these denominators multiplied by something to make it match the other? Right? So we're trying to figure out what number, what term should I make everything into, because I need them all to be the same. Okay? So this is what they're going to look like. Now remember, these are the easier. Okay? Now I'm going to show you how I recommend you do the work. It doesn't mean you have to, but this is going to be how I recommend that you do it. I'm going to try to show you the fastest way to do them, but it's still going to take us some time. And it is going to be a little annoying because I am going to write some steps on purpose so that we can have an easier time simplifying. Okay? Now, the number one thing that I know people, when they look at this, they don't like is the fact that there's fractions, right? Fractions automatically mean that the problem has to be hard, right? So what I'm going to try to do is I'm going to try to get rid of the fraction. That's that little trick I'm talking to you about. I'm going to try getting rid of the fraction. But in order to get rid of all these fractions, I need to figure out a common denominator. Okay? So this is what I'm going to do. I'm going to write down all of the denominators that I see. Okay? I see a 2n, I see another 2n, and then I see a 2. Now, it would be really nice if all of these were identical. If they were all what? 2 what? It'd be nice if they were all 2n. Notice, 2 of them already are, but one of them is not, right? So what do I multiply this bottom one by in order to make it a 2n? Just an n. And now you would agree that 2n would be the same for all three denominators, right? All three denominators would be 2n, 2n, 2n if I just multiply the third one by n. Now, what I'm going to tell you is we just found out that the GCF is 2n because we were able to figure out that we can make all of these things into 2n, even if they didn't start out that way. But I was able to multiply the last denominator by n. I can make it match 2n. So this is what we're going to do so that we can get rid of every single fraction. Because there's two ways to do this. There's one way where I can eliminate all fractions, which I'm going to show you. That's the way I prefer because I don't like fractions here. Or we can multiply each individual fraction by something. Okay, little by little, and kind of build this new denominator. But I don't want to have denominators left over. I want them all gone. So I'm going to show you guys the fastest way to do it. Once you know what your GCF is, okay, because we all agree that 2n would be great if we can make everything 2n, and I showed you we can. We can make everything 2n. Once you know the GCF, you're going to multiply everything by the GCF. Okay, every fraction by the GCF. So look, I'm going to put my, I should have kept this in green. Give me a second. Let me change the color because I think that'll make it a little bit easier. You know what? I'll go to blue. That'll be 2n. The GCF, like I said, is 2n. Because I'm going to use blue as like, look, this is the new stuff. So here we go. I'm going to multiply by 2n. Okay, and then my original problem is still n minus 1 over 2n equals 2. Everything is going to get multiplied by 2n. And right now you'll see why I'm doing everything. And this is the part that I'm telling you guys, don't get lazy. Write it out. Okay? I know this takes time. I know it's annoying to rewrite it. But it's helpful. Okay? Because notice how for the very first fraction, the 2n times n minus 1 over 2n, I can cancel that out. It's gone. No more fraction for the first fraction, right? It's gone. Notice the second fraction, 2n times 3 over 2n. That completely cancels out. So I don't have a fraction there anymore either. What can I cancel out for the last fraction? Can I get rid of all the 2n? No. What can I get rid of? Just the 2. So the 2 with that 2. And look what happens once I rewrite this. So on the left side, all that's left is n minus 1. On the right side, it's just 3 minus n times 1 is n. And there you go. This big old problem that has all these fractions, I made it into a linear problem that you learned in Algebra 1. I made it a lot easier. All we have to do is combine like terms. So let's add n to this side, right? We're going to move that negative n to the left side. So n plus n, that's 2n minus 1 equals to 3. Now let's add a 1 over to this side. So that's 2n equals to 4. And if we divide both sides by 2, what's n? 2. And I'm done. I solved it. I got a problem that normally is difficult because it has tons of fractions. I'm supposed to do cross multiplication and all this other stuff, right? I worked my way around it by finding the GCF. And by finding the GCF, then I kind of like cheated in a sense, and I multiplied everything by the GCF. It allows me to cancel out all my fractions. And then my main equation comes out to something really nice and easy, right? And then I just got to solve. And that's it. That's all you got to do. There's an easy way to do these problems. There's a harder way to do it. I'm showing you the easiest possible. Well, I guess it's more easier if you do everything in your head. But this is what it looks like as you take your steps. Okay? So little by little, just take the time to write it out so that you can visually see what you're canceling. Okay? So let me show you this next one. So I have a 1/6 equal to a half plus a 2 over n. All right, so we're going to solve 1/6 equal to 1/2 plus 2 over n. Again, I told you guys in the last problem, write down your denominator. So I got 6, I got a 2, and I got an n. Now I got to try to figure out, in this case I got numbers and letters. So what numbers and what letters should I make this into? What's the greatest common factor, right? So, or sorry, not the greatest common, the common factor for each. Okay, so if you look at just the numbers, so we just have 2 and 6, what's the best number to use that they can all go in? Well, no, 2 divides them, but I'm saying what can they go into? 6, right? 6 goes into 6, 2 goes into 6, right? So that's probably the best number. Okay, that's our common factor. That's something they can all go into. Okay, our common multiple, I guess you could call it as well. So since I want to choose 6, that means I'm going to multiply this by 3. So that gives me a 6. Okay, and then the n I want to multiply by 6 to make that a 6. So right now, all of them are going to be 6s. But I have a letter. So I got to make sure they all have the letter n. That means I get to multiply the 6 by n, this by n, and then the bottom one already has it. So notice 6n, 6n, 6n. They're all the same if I do that, right? I got a common multiple for all of them. Okay, so that's the hard part when you're doing these problems. You got to ask yourself, how do I make all of these denominators match? What number should I write for them? What letters should I put for them? Right? How do I make them all a common denominator? So The 6, all I have to do is multiply it by n to make it 6n. The 2, I have to multiply it by 3n to make it a 6n. The n, I just got to multiply it by 6 to make it a 6n. But you can see all of them have the same value, 6n. My common multiple, or my common denominator, if you want to call it, the common denominator is 6n. So what I'm going to do is I'm going to multiply everything by 6n. So 6n times 1 over 6 equals 6n times 1 half plus 6n times 2 over n. And now you basically cancel stuff out. What can I cancel out for the first fraction? The 6. So that's gone. What can I do with the second fraction, the 1 half? 6n times 1 half. Because I can't cancel out the 6 completely, right? I can reduce it. Between 6 and 2, this will become a 1, this will become a 3. And then on the last one, the n. All right, let me rewrite what's left over. This is n equals to 3n plus, what do we have, 12? So 6 times 2 is 12, and then on the other one I have a 3 times 10. Notice all my fractions are gone now. Okay, I just have a linear equation. So I'm going to go ahead and start moving things around. Let's get this 3n, throw it over to the left side. That's a negative 2n equals to 12. And if I divide both sides by a negative 2, n is negative 6. And there's my n. This is the hard part, guys. That's the hard part. You're trying to figure out, how do I get all these denominators to be the same? What do I multiply this one by to make it kind of look like this other one? Right? I want them to kind of match. Okay, how do I do? So we're looking for a common denominator. Okay, so that's the tough part. I actually think, like I said, that the harder ones are easier to figure out than the easiest. But these are considered easy. Some people really like these. I'm more partial to the tough ones because I think they're easier to spot. All right, so we have example number 3. We're solving 1 over 2p minus p plus 1 over p equals to 2 over. I'm going to write down all my denominators. 2p, a p, another p. Okay, what would be my common denominator? What would I like it to be? A 2p, a 2p, right? They should all have a p, which they do, and they should all have a 2, which they don't. So I want these all to be 2p. Now the top one is already a 2p. The middle one, I got to multiply it by 2. The bottom one, I got to multiply it by 2. That's going to give me a 2p from top to bottom. Okay? That's my common denominator. Okay? So my common denominator is 2p. So I'm going to multiply everything by 2. So 2p times 1 over 2p minus 2p times p plus 1 over p equals to 2p times 2 over p. And then I start canceling stuff out. What can I cancel out in the first fraction? The whole thing, right? 2p, that's all gone. What about the second fraction? Just the p, right? So that's gone. The last fraction, let's see as well. So that's gone. So all my fractions are now gone. Again, I don't like fractions. I don't like decimals personally. I know I can do them. I'm a math major. I should be able to, right? But if I don't have to deal with them, I won't. So this is my way of getting rid of them to make it easier on me. I'm doing this in my head. So here we go. Let's rewrite this. The first fraction is just a 1 minus. The next fraction is a 2 times p plus 1. And the last fraction is a 4. Okay? I'm going to do 2 steps at once if you guys don't mind. I'm going to move this one over here by subtracting it, but at the same time, I'm also going to distribute that negative 2. Okay? So 2 steps at once. So the 1 goes over to the 4 side, that's subtraction, so that's going to be equal to 3. And then if I distribute negative 2 into p plus 1, I get negative 2p minus 2. And now I got to solve. Again, this is called a two-step problem. This is like chapter 1, section 3 or 4 in algebra. So this is 2 years, right? So let's add this 2 over here. I get negative 2p equal to 5. And then if I divide both sides by negative 2, I get p equal to negative 5 halves. Fractions are okay. It's not a problem if you get a fractional answer. Okay? There you go. There's your answer. Negative 5. By the way, I'm doing homework problems for you guys. So that's what I'm going to do for. I hope you guys don't mind. It's going to be 20 minutes for the lesson. I figure the more I do, the more I can help you take some of these problems. Before I get to this, I think there's one more. Yeah. Before I get to this last one, do you guys have any questions on examples 1, 2, or 3? Again, the hard part is getting your common denominator. Now, you might say, well, that wasn't that hard for this one. Well, no, it wasn't that hard for that one because they all kind of like flowed, right? P, 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 and some were just missing 2, right? The previous problem was a little bit tougher because we had a 6, a 2, and an n. You had to think, well, what should I multiply these things to make them match? So we thought, well, let's make them all 6n. We can make them 6n, all of them. You could also make them 12n. Okay, you can make them 24n. It would have worked as well with bigger numbers, but we're trying to find the smallest, right? The smallest. So the rest of your numbers start to blow up. So we're trying to find the smallest number that they all go in and the letters as well. And you can see in the first example, we had 2n, 2n, and a 2. So we just had to deal with the last denominator, 2 times 10, right? So this last one, example 4, is a little bit tougher than the other 3. But it's not that much tougher. Just remember, we're trying to figure out what do we multiply in terms of numbers, what do we multiply in terms of variables to make them all the same. Okay? So let me write down all of the denominators. So I got 2x, an x, and an x squared. So remember, always think about the numbers first. What number should they all have? A 2. All right. So that means I need to multiply this by 2 and this one by 2. So now they'll all have 2. So that's good. Okay, they're all going to have a 2. What letters do they all need to have? An x squared. Not just an x, because if we just do an x, the one at the bottom has x squared. That has 2 of them. So they all have to at least have 2 x's. So I got to multiply the top one by what? Just 1x. What about the bottom one? Also just 1x. And the last one, it already has it. Just to show proof, this is 2x squared. 2x squared. 2x squared. So now they're all common, right? They're the same. So these are common denominators. Okay, 2x squared. That's what I'm going to multiply everything by. Okay? I'm multiplying everything by 2x squared. So, 2x squared times 3 over 2x plus 2x squared times 5 over x equal to, this is the step that I tell you guys, like, don't get lazy, do it. Make sure, if you want to do it in your head, fine, but I'm always a big fan of showing it. That way you can kind of see the crossing out of things as it happens. So there you go. I got the common denominator. and I'm multiplying it times everything. I usually, just so you know, whenever I do this, I usually write the 2x squared in the front and then put a big bracket like that. And I don't write the blue ones on the inside. I leave it like that. And then me mentally, I just do it. I cancel it. But that's, again, oops, that's not the thing I wanted to say there. Again, that's me having 20 plus years of doing this. So it's okay. But if you're still a little like, I don't know if I want to try to go too quickly, just do this. This is what I used to do. Okay, write it up. All right, what can I cancel out on the first fraction? A 2 and how many x's? Just 1, right? So this becomes x to the first. Okay, what about the second fraction? Just the x, right? So 1x here with that x there. And what about the last fraction? An x squared. That's gone, that's all right. Again, this is probably the hardest type of problem you're going to see on your homework. So again, if you don't think this is that difficult, that's why we call these the easier ones, right? The harder ones, they look a little bit. I'll let you see what they look like now. So anyway, let's see. What's left over on the first fraction? There's an x and there's a 3, so that's going to be 3x. On the second fraction, there's a 2x times 5, so that's 10x. And on the last fraction, there's a 2 times 5x minus, minus 1. Yeah. You okay so far? So 3x plus 10x, that's 13x. I'm going to distribute right here. That's 10x minus 2. I'm going to move that 10x over by subtracting it. That's 3x equal to negative 2. And I got to divide both sides by 3. So I get x equals to negative 3. And that's my solution. Again, I think these problems, they call them easy because they're not that hard to do once you get over that tricky step. Once you figure out the correct denominator, the rest kind of flows, pretty straightforward. But the hard part is trying to think your way through, okay, these are my 3 denominators. What can I make them all? They all have to match. What should I do? Okay? What should I multiply them by? What should I do? Okay? So, other than that, I think it's pretty straightforward. I'll show you what tomorrow's looks like really quick after I end the video. But let me go ahead and end the video. I'll give you guys a homework.